Salam and welcome. In the previous video, we learned a lot of things about how to change primary alcohols into aldehydes in form of oxidation process. And you just remember that we used potassium dichromate. And we also, if we make further oxidations for aldehyde, we can get something called carboxylic acid. And now today's lesson is the opposite of the oxidation, which is reduction process. So the reduction process in our lesson, we're going to return the aldehyde back to primary alcohol. But in this case, this process is described in terms of reduction, and that's why we can describe it into hydrogen in between F square brackets. So let's take a real example of aldehyde, and then we can explain the stuff. So let's take ethanol, CH3, CHO. We're going to make a reduction, and we can put hydrogen in here. The product that we're going to get is a primary alcohol, and you just remember that this group will change to CH2OH. Okay, perfect. So the compound will be produced in here, CH2OH. So this is primary alcohol. You just notice that the hydroxyl group, which is the OH, is bonded to carbon, and this carbon is bonded only to an alkyl group, and that's why it is primary alcohol. But you have to put in your mind the equation in this case must be balanced well. And now let's count the number of atoms before and after the arrows. As we can see, the number of carbons here, we have 2 carbons here, we have 2 carbons. And what about the oxygens? Here we have 1 oxygen, and here we have 1 oxygen. So the oxygens and carbons are equal. Now what about hydrogens? We have 1, 2, 3, 4, 5, 6 hydrogens. And here we have 3, 4. Okay, so how can I change this 4 hydrogens to 6? We have to multiply this by 2. And now if you recount the number of hydrogens again, you will have 6 hydrogens on both sides of the equations. So we have 4 plus 2, then it's equal to 6, and then here 6, then this is the balanced equation. All right, so what is the reducing agents that we're going to describe in our reaction? The reducing agents that we're going to learn, we have 2 reducing agents. Okay, these reducing agents, the first one is called lithium, Tetra, Hydrido, Aluminate. Okay, and this is a very strong reducing agent. And you have to put in your mind, we have to put this in solvent. And the solvent that we're going to use is called ether. And by the way, the ether, it's a homologous series in organic chemistry, and it's described as R groups that contain oxygen atom in between. So this is the ether. The general ether that we can use in such compound is called Diethyl Ether. And it means that you have 2 ethyl groups and we have oxygen in between, C2H5. So this is the diethyl ether, works as a solvent that you have to put in here. In addition to that, because this is a very strong reducing agent, we can do the reactions at room temperature. Okay, so there is no need to heat, it's strong enough. And put in your mind, we don't add water at all because water is reactive, and that's why we use ether instead. Okay, so we mentioned that we have 2 reducing agents. The first one is lithium tetrahydrido aluminate. The second reducing agent, which is not as strong as lithium tetrahydrido aluminate, but it's mild a little bit reducing agent, and it's called sodium tetrahydrido borate. Okay, NaBH4. Okay, And in this case, as we mentioned, it works as a high temperature, or let's say you must apply heat to make this reaction. And it must be dissolved in alkaline solvent. Okay, so you have to put alkaline solvent with heating, and then it will work as reducing agent. Okay, so these are the two famous reducing agents that we're going to use. We just noticed that we can change the aldehyde into primary alcohol by reducing agent. We describe the reducing agent process, or let's say reducing agent in terms of H in square bracket. And now let's go to the second part of reduction process. If you have a ketone, let's take this one, CH3, and we just apply, let's say, lithium tetrahydride aluminate in a dry ether. And what do you think the product will be in this case? You have to put in your mind the ketone is reduced to secondary alcohol. Okay, so as we can see, this group will change to CHOH. Then you have CH3, COH, and here you have another H, and here you have CH3. By the way, if you look to the number of hydrogens, we just noticed that we increased the number of hydrogen. And actually, this is the definition of a reduction process, which means gaining hydrogens. So you can describe this in this form, or you can describe it in terms of equation. So you have COCH3, we added hydrogen, and then we have this product, which is CH3, CH, OH, and then here we have CH3. There's no change in the number of carbons, no change in the number of oxygens, but the only change is in the number of hydrogens. And as you can see, we have 6 hydrogens in here. We have 3 and 3, and here we have 2. Okay, then we have to multiply this by 2, and then this is the equations that we have.